There are many ways to solve equations, and so today we're going to be really focused on 711C on solving these one variable two-step equations. And so as we go through, I want to make sure that you write this down. 711A, as we prepare to look at models and then word problems to then write equations. So on the STAR test, you may be asked to examine the model of an equation and then to solve using that model. And so today we're going to actually use these models to help us solve these equations. And then for each problem, we can use both a model and a more procedural method. And the goal is for us to see the connection between the two methods. So let's go ahead and review this problem together. We have the model that represents the equation 2x minus 1 equals negative 7. So here we go, thinking about the balancing scale, showing that the left side has to equal the right side. And we want to know what value of x makes 2x minus 1 equals negative 7 true. So in other words, we want to know what does x represent in order for this to be a balanced part. Okay, so we know that we have our x variable because it's labeled x, and then I see a lot of negative ones that are also within squares. So we know that if we are going to make it equal or balanced, that whatever x is would have to maintain the same amount as this scale over here. So let's just double check and make sure that we know what is on each side. So I see two x's here, so x plus another x plus a negative 1. So the left side of our balance has to equal the right. And there are 7 negative 1. So I could write negative 1 plus negative 1 plus negative 1, negative 1. Or because I add them all together, I see that that's negative 7. Because they already combined like terms for us, we see that there are two x's. So we can rewrite it as 2x plus a negative 1 or minus 1 like they wrote it in our equation. And sure enough, we end up with the same equation as what is given. So again, it's super important to know what we are seeing, and so we can represent that into an algebraic equation as shown here. Well, I know that the goal is to find x. So we want 1x all by itself, right? And we need to get rid of everything else in order to determine what 1x is. And so what I can first do is take away 1. So if I'm using my model and I take away 1 on the left, I have to take away 1 on the right. So if I rewrote my equation, I see that I have 2x equals and now negative 6. So the way I can show that, let me move this over actually. The way that I can show that algebraically, instead of using the model, is by adding 1 to both sides, which that takes away the negative 1 because we get 0 and we're left with 2x. And then because our tic-tac-toe chart reminds us that because we have a negative and a positive, we have to subtract and keep the sign of the bigger number. So surely enough, we get negative 6. And so this is why it's super important to be able to look at the model, because sometimes integers cause some kind of confusion and we're not sure of what operation to do and what the sign is, yada, yada, yada. So the model makes it super easy for us to visually see how to get rid of and isolate the variable. So now I'm left with two x's, and I know that they have to equal negative 6. So that means two groups have to equal negative 6. So I could break up these negative 6's into two groups evenly. And I see that there are negative 3 in each group. So one x is negative 3 and the other x is negative 3. And the way I can show that algebraically again is to divide both sides by 2 or cut them in half. And I see that negative 6 divided by 2 is 3. And if I'm confused on the sign, a negative and a positive gives me a negative sign. So sure enough, x equals negative 3. So I see my answer choice right here. Now, if I wanted to double check, I can go through and substitute or redraw out negative 1, negative 1, negative 1, negative 1, negative 1, negative 1, instead of having those two x's, plus the negative 1 has to equal 7 of these. So are there negative 7 over here? Yep. Are there negative 7 over here? Yep. So check, we did it correctly. So visually, we can use substitution within a model to determine if our solution is correct. Or algebraically, we can substitute into our equation and see if we get negative 7. 2 times negative 3 is negative 6 plus a negative 1. The signs are the same, so we are going to add and keep the sign. Signs are the same, so we add and keep the sign, and I see that that equals negative 7 on both sides. Alrighty, so we're going to go ahead and check and work on one independently.